So, have you had your fill of pointers yet? It is certainly reasonable to ask at this point, why do we have to know all this stuff? Well, one of the principal reasons for learning about pointers is so that we can dynamically assign memory as the need arises. You recall earlier in the semester when we were defining arrays. We define arrays at compile time. When we were writing the program, we, for instance, would declare an integer of array called numbers that had 10 elements. Okay, that's called static binding. We decide on the size of an array before we even run the program. But sometimes the need arises, or you're not able to define the size of an array until the program is running. If you define the size of an array after the program is running and create an array on the fly, that's called dynamic binding. And there's lots of applications of that. So the one application we're going to look at today is dynamic binding, or creating an array after the program has already started running. And you do that through the use of pointers. Let's see how that happens by going to this URL and examining the code. Okay, so at the beginning of this code, we define an integer variable to hold a size of an integer of an array that we're going to create. And then we declare a sum because we're going to perform a calculation. We initialize it with 0 and define it as an integer. So we create a prompt that says how many elements in your array, and we collect the response in that integer variable called size. Now, at this point, we declare an integer pointer called pz. That is, pz is going to hold a pointer that points to an integer array of the size the user just dictated. Because the user entered a size, and then we're going to use that integer value to allocate a block of memory of integers of that size. So for instance, if they said I wanted 10, then the integer allocation is going to be 10 times 4 bytes per integer, or an allocation of 40 bytes. And then pz is going to point to the beginning of that block of 40 bytes. Okay, so then we're going to begin this for loop. Remember, a for loop has an initialization segment. We're going to initialize the counter variable I at 0, and then the condition for it to continue is that the integer has to be smaller than the size that the user selected. And then after each loop, the counter variable is going to increase by 1. So then we have a prompt that says, give me a whole number. And then we're going to suck in that whole number into the indexed offset of that pointer. Now remember, the index starts out with 0. The pointer is pointing to the beginning of the block. So the pointer beginning of the block with the 0 offset is pointing to that first integer. After we complete this loop, after we've collected it and stored it, the variable I is going to increase by 1. And so we're going to prompt the user again by saying, give me a whole number. And then it's going to suck it in. And since that next number is 1, it's going to put it at the first offset of 4 bytes from the beginning. And then the second offset of 4 bytes from the beginning. And then the third, etc., until we've reached 1 less than the size. And you'll understand that if we went all the way to the size, we'd be to the very end. So we have to be 1 less than the size so that we can have that last 4 bytes to store a value. Now, we're going to then indicate that we're going to calculate the average of those numbers, and we're going to loop through that block of memory. This time we're going to extract the value. Now, I think it's interesting at this point that we just have to use the pointer with the offset, and that's going to return the value at that location. We don't have to use that asterisk indirection operator, although we could. And then we're going to sum all of those values, and we're going to divide that sum after we cast it to a float, because we might anticipate a decimal. We're going to take that sum and divide it by the number of numbers, which is the very definition of average. So, isn't this interesting? Again, as a review, we ask for, on the fly, this program is running, we ask for how many elements do you want in your array, and we collect their answer in the variable size. We then allocate new memory, which will return a pointer to the beginning of that block of memory. And because we declared it as an integer pointer, every time we increment that pointer by 1, we're going to jump 4 bytes. We're going to jump to each new integer. So we set up a for loop, and we're going to go through the for loop, and that for loop's index is going to keep changing the offset from the beginning of that pointer to block of memory, and that's where it's going to store their input. Then we're going to loop through it again, and we're going to use the index of this loop again as an offset from the beginning of that pointer, which points to the beginning of the memory. And then we're going to do a simple calculation of average and print it out. So that's our first application. It's called dynamic binding of arrays. All right, what a journey we've had examining the ins and outs of pointers. And now it's time to put your new education to good use. The last slide and the last URL we looked at demonstrated how you could dynamically create an array using pointers. We're just going to extend that just a little bit for your assignment. I'm going to have you create 2 parallel arrays. I want you to create 2 arrays. One array is going to have a monthly budget item, and the other array is going to hold the value of that budget item. The size or the length of the array is going to be dictated by the answer to the question, how many budget items do you have? So go back to that last dynamically generated array and try to figure out how that was done. And just add into it another array. Change your prompts a little bit so that you're asking for budget items. And then add a prompt and an input so that you can add data to that second array. It really isn't as hard as it might appear at first blush. So give it a shot. I'll have a Dropbox for you to submit it to, and good luck.